Hello again. Now we're going to be answering part B and part C. So to start us out, let's do part B. Given the correspondence in triangle AMW similar to triangle CDA, list all corresponding pairs of angles and corresponding sides. What is the ratio of corresponding pairs of angles? Well, real easy way to answer part 2. By definition, when the two triangles are similar, then all the angles are congruent. That means is that you can think of ratio as the same thing as scale factor. If all the angles are congruent, then your scale factor or your ratio would just be 1, because you just essentially have the same angles over again. So to answer this part, your ratio would be a 1-to-1 ratio. Now we can answer the first part. List all corresponding pairs of angles and corresponding sides. So to keep track of this, I'm going to start with this. If you imagine our original triangle here, right? Where we started. Our vertex AWM, or that angle I should say, AWM, is where I'm going to kind of be tracking the triangle as it moves. Well, when we rotated it, the corresponding angle would shift to this position. Then, when we translated it down to the purple, it just shifted down here. Finally, when we dilated it, it became that angle. So this angle here corresponds with that angle there. So what angles are that? That's angle AWM and angle DAC. So our one angle AWM, and I already forget what the other one was, DAC. Angle DAC. That's our first pair of corresponding angles. And you can do a similar process with all the other ones. I'll try to do a new color for this. So let's look at this angle M here. Well, when we rotated the red to the blue, angle M is going to move over here. And again, when you slide it down, it moves over here. Finally, when you dilate it, well, it actually stays in the same position. Oh, I'm sorry. When you dilate it, it stays in the same position as it was from the purple triangle. So we have that the yellow angle, we can just say it's angle CDA, is going to correspond with angle WMA. So angle CDA and angle WMA. I apologize if that's a little hard to see. And our third angle, I'm running out of space. I'll just put it over here, whatever. The third angle is going to be, well, the one we have left. Well, which one do we have left? We can just really skip to the last part now. We have this angle and this angle. So that would be angle DCA and CAM. So angle DCA and angle ACM. Got cut off a little bit at the end, but you should know what I'm talking about. It's just the two angles right here labeled in red. So those are all the pair of corresponding angles. Now I'm going to list the corresponding sides on part C. And it's also asking us what the ratio is. Well, we already found out what the ratio is. It's the same thing as the scale factor. So your ratio is equal to 2, which is the same thing as a 2-to-1 ratio. well, what actually are the corresponding sides? Now, after you find the angles, this is a little bit easier to keep track of. Just look at where the angles are and kind of match it up with that last triangle. So if I look at, you could imagine this black angle and the red angle. Well, on our first triangle, that's side WA, right? This length here. And then if I look at our green triangle, the red angle and the black angle is CA. So WA corresponds with CA. WA and CA. That's our first corresponding side. Our second corresponding side, we can just say, is that side that contains the red and the yellow angle, so AM and OC. So 2 is AM and OC. And finally for part 3, or not part 3, well, the third corresponding side is from the yellow to the black, which is WM and DA. WM, wait, yep, yellow and black. WM and DA. So WM and DA. And that completes problem number 2.